Hi, everyone. I'm really excited to share the results of an interesting project we worked on recently with you today. We were doing an LCA for a medical device, a basic Luer lock syringe, and it got me thinking, who else has done an LCA in this space and how accurate and how close are our results going to be to their work? And so, what I want to share is just kind of how we recreated somebody else's work from their inventory. So, we borrowed this from the Apiject LCA by Matthew Eckelman. And basically, what we did to get started was pasted in the inventory data from their study to EcoScan. I simply let EcoScan start digesting that information. I gave it one prompt. I said, I'm not sure if there's any major differences. I just want you to use that inventory basically. And I went straight to the bill of materials and straight into the graph data model. So I'll walk you through how we took those results and the graph that was built, kind of tidied up, modified that graph a little bit, and reproduced the results of that study.
So the first thing I did was tidy up the graph. This graph was built by EcoScan, but it included some transportation legs that weren't necessary. So I deleted that transportation information and was pleased to see that the actual inventory values from EcoInvent were pretty well represented and found pretty accurately. There were a couple of things I had to tidy up. Sometimes we grabbed a national or regional value when the study used rest of world or global average. But basically, the work here of tidying up was to just confirm the inventory values and start organizing the cards into the kind of subcomponents and subassemblies of the actual syringe and needle and packaging. So really quickly, we can see here that the graph starts to take shape. This is going to look very similar to kind of the end product in a couple more minutes. But I'm basically tidying up the cards, again, confirming the inventory values and making sure that this looks like the individual steps that are represented in the study. Did a couple more things, to make sure that we were in the right direction. Added in some final transportation and distribution, added in some end-of-life scenarios. And then really we were able to quickly get into a really important piece of building a study like this, being able to check our errors in a simplistic and intuitive way. So what I'll highlight here is, I quickly pulled up a Sankey diagram and saw that instead of using milliliters of water in the sterilization process, I had used meters cubed. And instead of using grams of steel in the assembly of the actual needle, I had used kilograms. And having these visualizations let us just really quickly check our work and make sure that we haven't made any of these glaring errors and correct them quickly if we have. So thanks to EcoScan and the graph view, within about 10 minutes, we were able to recreate this study and just kind of validate the direction we were taking our own model, that we had this similar boundaries basically, and we're able to get the same results plus or minus 5%. On the left, we have the values and confidence interval from the Apiject study, and on the right, we've got the values calculated in Carbon Graph. And for the global warming potential value, we're within about 2.5%. And it seems like this minor difference can be explained by marginally different EcoInvent values, or the fact that we ran our model in Tracy 2.1 and the paper used Tracy 2.2. Ultimately, we were able to recreate these results quickly, and it seems like a powerful new way to use EcoScan to rapidly establish accurate baselines and set up parameterized models that can be used by others. I hope you've enjoyed this new use of EcoScan and the Carbon Graph modeling interface. This model, like every other that we do in this series, will be available in Carbon Graph community models for any user who has the appropriate license, in this case, an EcoInvent license. And there's a link to the peer-reviewed Apiject paper in the description with additional results. Our team is really excited about the opportunity to build collective knowledge and make models more widely available. If you've got a paper or model you'd like to recreate for others to use, let us know. Thanks.